Welcome back to myclass.com. Descriptive statistics, another method for calculating in a numerical way, that is measures of variability. We have discussed measures of central tendency in the previous video, that you can refer that video first. Now we are going through measures of variability. So the measures of variability means measures of variability is a summary statistic that represent the amount of dispersion in a dataset. I have already said that it is not concentrating on a typical value. Measures of central tendency describe the typical value, but the variability is how far away the data points tend to fall from the sender. Which one is a very small value and which one is the very greatest value in the dataset? All the values are included in the calculation of measures of variability. Okay, we talk about variability in the context of distribution of values, how the values are distributed in a data set. But the measures of central tendency is concentrating on the central value, okay, typical value, that is concentrate on the center of that data set. Okay, so the low dispersion indicates that the data points tend to be clustered tightly around the center. If you are calculating the measures of variability in lots of ways, we are calculating in one of the way and we are getting a low value, that means the data is clustered, that is clustered around that value. Okay, if it is a mark data set, that is all the students got marks around the 50-55 or 60 to 70 marks, 60 to 70 range, all the students have scored like that. But it is a high dispersion, that is means that some students got the very lower value and some students got the full value, like that. It does go through like this. Okay, so that is the importance of measures of variability. Now these are some common way to calculate the measures of variability: range, interquartile range, quartile deviation, mean deviation, variance, standard deviation, and coefficient of variation. I think seven methods are that, but very easy because each methods are interconnected and also connected to our central tendency. Also see here the quartile is the okay. So first we are going through the range. So what is range? Largest value minus smallest value in the data set. Easy. If the 5 is the smallest value and 100 is the largest value, we can say that 100 minus 5, 95 is the range of this data set. So what is interquartile range? Measures of variability that overcomes the dependency on extreme values in the interquartile range. So we are calculating by difference between Q3 minus Q1. Q3 is the third quartile and Q1 is the first quartile. So the Q3 minus Q1, that is the value for IQR, interquartile range. In other words, interquartile range is the range for the middle value, 50% to the data. We are getting this value. After we are getting this value, we can get the range for the middle percentage of the data. Now the quartile deviation, that is also very easy. When we are calculating the interquartile range IQR divided by 2 is the quartile deviation formula. Q3 minus Q1 divided by 2. Q3 denotes the upper quartile and Q1 indicates the lower quartile. So also quartile deviation is also known as semi-interquartile range. So after calculating interquartile range, when we are dividing it with 2, then we will get the quartile deviation. So Q3 minus Q1 divided by if this is our data, we have already discussed in the previous video. So the Q3 is 3600 and Q1 is 3465. So after subtracting 3600 minus 3465, 135 is the IQR. IQR is equal to Q3 minus Q1, that is 135. So what is quartile deviation? Quartile deviation is 135 divided by 2. Next is mean deviation. Mean deviation is very easy. If we are calculating the mean for that data set, we are subtracting each value with that mean. The difference between xi and the mean. Xi is sample. The mean for the sample is we are calculating x bar, is it? And mu is for population. If we are talking about the population, we are denoting it with mu. If we are talking with a sample, if it is, we are denoted with the x bar. But the calculation is very easy. No need to worry. So that is the mean deviation. For calculating the variance, the next aspects of measures of variability, we want to calculate the mean deviation first. Okay, so the variance is a measure of variability that utilizes all the data. The variance is based on the difference between the value of each observation and the mean. That is the mean deviation. Then we are calculating with then equation. So if we are calculating the variance for a sample, it is called as sample variance. That is, we are first calculating the mean deviation, then we are squaring that deviation and then dividing this with n minus 1 if it is a sample. If it is a population, we are squaring this mean deviation and adding and divided with the n, whole value, whole number of data in that population. Okay. The sample variance are we are denoted by S square and this is we are denoted by sigma square. So this is the equation. Population variance is summation of I to n x minus mu whole square divided by n. This is the population variance. Xi is value for ith element, mu is the population mean and n is the population size. When we are calculating the variance for population, we are dividing it with the n value, that is total number of elements in that. If we are calculating the sample variance, only the difference is we are dividing with the n minus 1. Now let's go with the standard deviation because it is very related to sample variance or population variance. The square root of variance is, we can call it as standard deviation. So the standard deviation for a sample is S square. So the square root of S square is S. We are calculating it with this whole calculation and we are calculating the square root of this calculation. And the population sigma is summation of xi minus mu whole square divided by n. After calculating the variance, we are calculating the square root of that value. We will get standard deviation very easily. So let's go with an example. So it is a sample. Okay. If it is a sample, then we are calculating x bar, the mean. The total is, it is for 72. So the mean is 72 divided by 6 is equal to 12. So we want to calculate like 17 minus 12, 5 minus 12, 22 minus 12, 7 minus 12, 9 minus 12 and 12 minus 12. If we are calculating like this, our values, this one 5 minus 7, 10 minus 5 minus 3 and 0. After that we are squaring each value. 5 equal to 25, 49, 100, 25, 9 and 0. So how we are calculating the sample variance? Summing all this value, that is 208. 208 divided by how many values are there in the sample? 6. So the 6 minus 1 is 5. So 208 divided by 5 is 41.6. That is our S square, sample variance. And the square root of the sample variance is standard deviation for this sample, that is S equal to 6.45. If in the question is like that, we want to calculate the population variance of this following that data, you can get that question like this also. For that, only the difference is the calculation is very same. Here instead of x bar we are doing mu divided by n minus 1 instead of we are using divided by n. That is the only difference between the population variance and the sample variance example. Okay. Now one more thing is there in the measures of variability, that is coefficient of variation. So how we are calculating coefficient of variation? It is very easy. We are calculating and we are expressed in percentage. Okay. It is like this, standard deviation divided by mean into 100. Okay. So in the previous example, the standard deviation is 6.45. Is it? So 6.45 divided by 12, the mean is 12 into 100. So 53.75% is the coefficient of variation of this data set. Clear? So that is all about the measures of variability. 7 measures of variability calculations are there, that is range, interquartile range, quartile deviation, mean deviation, variance, standard deviation and coefficient of variation. Is it clear? Thank you for watching.